All right, hello once again, Jeff Scott of Rankin Technical College. And as part of my never-ending quest to try to make things easier for students in the AWD 1000 web development technologies and AWD 1111 database-driven web development classes to make their life a little bit easier and make concepts, etc., easier to understand, I've been doing a series of video presentations based on some of the ebooks by Mr. Flavio Copes. So far, I've done a series of presentations on his HTML ebook, his CSS ebook, his JavaScript ebook, his ES5 to ESNext ebook, his React ebook, and I'm now in the Node ebook, and next I'll do the Express. All right, this is the longest of the ebooks. It's almost 190 pages, and I'm about 96 pages in. Now, they say here, when you write JavaScript code, you might want to delay the execution of a function. Learn how to use set timeout and set interval to schedule functions in the future. Now, some of you have probably already seen me give this little shtick that I'm about to give, but I'm going to come in here to images.google.com, and I'm going to show this. Wish I'd find it. That's more or less the kind of picture that I want to show you. Okay. And what else? That one will do. All right. No, I guess it won't. Let's try that one. And it doesn't like that one either. Oh, something goofy is happening. It says I'm connected. That'll work. All right. Now, why am I doing this? Well, I want to try to explain to you set timeout and set interval. All right. Now, back when I was the age of most people watching this, this is how we got up in the morning. You had an alarm clock that you wound up, and it had on there a little thing on the top when you pulled it off. So if I'd set the alarm, let's say right now it is 5:22 a.m. So let's say I'd set the alarm for 6 o'clock. All right. I would set it for 6, and I would pull that little knob here up. Then when 6 o'clock came, the alarm would ring. I would press that down to turn it off, but it was a one-time shot. If I went back to sleep, unless I reset the alarm clock, I could be dead in the water. Not a good thing. Well, time went on, and then we had things like clock radios, where if I set it for 6 o'clock in the morning and it went off and I was still tired, there was typically up here like a snooze button, maybe here or someplace else. And if I pressed it, it would let me sleep for about 10 more minutes, and then it would go off again, and I could hit snooze again. Well, what does this have to do with anything? Well, set timeout is like the one-time thing. You set it and forget it. The set interval is more like working with a clock radio. Now, again, that's my definition, my explanation for whatever good it does or does not do. All right, so set timeout, as it says, when writing JavaScript code, you might want to delay the execution of a function. That's the job of set timeout. You specify a callback function to be executed later, and then you let it know how long until you want it to happen. Now, the number that you put in here is a number in milliseconds, where 1,000 milliseconds equals 1 second. All right. So, if you want to specify the timeout delay to 0, the callback function will be executed as soon as possible, but after the current function execution. We already saw that. This can be especially useful in blocking the CPU on, as it says there, on intensive tasks. You know, things like database reads, or when you got to do something where you go out to the internet, etc. Or heavy calculations. There's all sorts of reasons that this might happen. Set interval, as mentioned there, is Similar to set timeout, but with a difference. Instead of running it once, it will continue to run it forever. Now, since there is a set timeout, there's a set interval, there is a clear timeout and a clear interval as well. All right. It says, they say here, it's common to call clear interval inside the set interval callback function and let it determine whether or not it should run again or not run again. All right. So a set interval starts a function every n milliseconds, where n is the number you set, without any consideration about whether or not a function has finished its execution. If a function always takes the same amount of time, everything works fine. But otherwise, there can be overlap. So as it says, to avoid this kind of overlap where you could potentially have problems, a recursive set timeout can be called to let it know when the function finishes. Call this. All right. All right. Now we get into probably the most hard thing for people to understand, and that is talking about callbacks, from which we go to promises, from which we go to async await. All right. Now, as it says here, JavaScript is synchronous by default and is single-threaded, which means that it does things one after the other. It works on something. When it's finished, it starts on something else. As further, it also means, as it says there, that code cannot create new threads and run in parallel. All right, so we're going to look in here about what asynchronous is, how JavaScript has attempted to figure out this problem or these problems, and we start with callbacks. Computers are asynchronous by design. It means things can happen independently of the main flow. What do I mean? Well, notice I'm in the middle of a PDF, but I can also come in here and go into here, and I can go into different windows, etc., and different stuff that I've got in here. I can do that without really any kind of problem, because again, this is meant to be asynchronous. In current consumer computers, every program runs for a specific time slot and then stops execution to let another program continue its execution. It says this all happens so fast that it's basically impossible to notice. Programs internally use interrupts to do this, and the author says that's fine. But realize that most programming languages are almost totally asynchronous, most programming languages are totally synchronous. And again, I've given this example before. I don't know if it's a good one or a bad one. No one has ever commented on it. But this is the way that I look at it. Human conversation is supposed to be synchronous. In other words, I come home and my wife says, "How was your day?" I'm assuming she's going to stop and let me tell her about my day. When I'm done talking, she's assuming I'm going to stop, and then she can respond and maybe tell me about her. When I get to the end, I might say, "How was your day?" Then I'm going to stop and let her talk. It's not like I try talking and she says, "How was your day?" and I start to tell her, and all of a sudden she starts talking. That would be more the asynchronous route. So as mentioned there, normally programming languages are synchronous, but provide some way to manage asynchronicity. All right. Usually it's a built-in language function or through a library. As it says, languages like C, Java, C#, etc., they're all synchronous by default. Some handle async by using threads, which spawn a new process. JavaScript, again, is synchronous by default and single-threaded, meaning code cannot create new threads, cannot run in parallel. So what does that mean? It says lines of code are executed in series, one after the other. So what does this mean here? This means that it should basically take the number 1 and assign it to a constant A, take the number 2 and assign it to a constant B, multiply 1 by 2, which gives us 2, and assign it to a constant C, log C, and then call a function called do something. It says, but JavaScript was born inside the browser. Its main job in the beginning was to respond to user actions. So in other words, if I've got a form on my screen, I am not sure exactly when the user might, if that's got a submit button on it, when the user might click the submit button. All right. So since the main job of JavaScript from the beginning was to respond to user actions, how can you do this synchronously? And as it says, the answer is in the environment. The browser provides a way to do this by providing a set of APIs, a set of application program interfaces that can handle this kind of functionality. More recently, Node introduced a non-blocking I/O environment to extend this to network calls, etc. So we're going to start this by going into callbacks. And it's early to end, but I want to give callbacks its due, and then we'll look at promises, give that its due, and then we'll look at async await. So I'll be back with that shortly.